How do we measure the objects in the universe? Hello people, this is Montes, and in today's video I'll talk about how we measure different objects as well as distances in the universe. This is my first video. I opened this channel to practice English as well as teaching some science. I hope you can enjoy it. Let's begin. Okay, we are going to start by looking into the units we use for measuring distances. In the first place, you are going to see that throughout the video that astronomers are used to make one measure in relation to Earth and make it standard. For example, one mass of Earth, the average distance from the Sun to the Earth, and many others. Understanding this, I present you the astronomical unit, which is defined as the average distance from the Earth to the Sun, and is equivalent to 149 million kilometers. This is widely used in terms of planetary systems to describe the distance in means of Sun-Earth proportions. Then we use the light year. I am sure that you have heard it a lot, but few people really understand its meaning. It is simple. It is just the distance traveled by light in one terrestrial year. This is approximately 9.46 trillion kilometers or 63,241 astronomical units. Finally, there is the parsec. But before I tell you what it is about, I want to explain you something, and that is parallax. Why is it so important, you might ask yourselves? Well, the first unit has to do a lot with parallax. Basically, if you look at a star from two different places at different positions in two opposite sides of the Earth's orbit, you can see that the star is moving. The observed angle variation between the 2 points is then utilized to estimate the distance to that star with help of trigonometry. So, if we consider 1 arcsecond of angle whose opposite side is 1 astronomical unit, then we clear the solution for the distance, and in this case is 1 parsec equals to 3.26 light years, and that is what we know as 1 parsec. Let's see some examples. Jupiter in average is at 5 astronomical units from the Sun. This means that it is 5 times farther away than the Earth to the Sun. In contrast, TRAPPIST-1 has all of its planets inside the orbit of Earth. This means that we have objects orbiting closer to their star than Earth does to the Sun. I am going to use now the light year for those big distances that you cannot even imagine. The closest star is at 4.2 light years away from us. This means that the light needs 4.2 years to travel from Proxima Centauri to our eyes. There are even more absurd distances. For example, if we were able to travel from one edge of the galaxy to its opposite, we will find that at the speed of light, it will take us 105,700 years of travel. You might be asking, where is the parsec? Well, I prefer to use light years, but it is indistinctly used with this one, at least for measuring distances to stars. In terms of mass, the kilogram is just too small, because the objects are so big that we would need many zeros to describe them. Instead, we use Earth masses for terrestrial planets like Earth. So when we find one exoplanet, it's likely to be described in this unit. There are cases where even this unit is small. Then we use Jupiter masses. The giant gas planets are often described in these units. Finally, to measure other stars, black holes, or even galaxies, we use sun masses. For example, Proxima Centauri b, which was discovered in 2016, has a mass of 1.27 Earth masses, or 51 Pegasi b, which has a mass of 0.47 Jupiters. Now let's see some examples to see that even sun masses are quite small in some aspects. Fortunately, we don't have Milky Way masses. Firstly, I am going to compare Proxima Centauri, which has 0.123 Sun masses. We can appreciate that it's small in comparison to the Sun. This is very normal for red dwarfs. Next, I will do the same for Sirius, the brightest star in the sky. As it is shown, it has above twice the mass of the Sun, but not twice the radius of the Sun. Now I am going to add the most massive known star, which is R136a. This one has more than 200 Sun masses, and 32 times the Sun radius. See? The size is every time growing, and here is my favorite star, Betelgeuse, whose mass is 11.2 solar masses, and its radius is so big that it must be measured in astronomical units, corresponding to 4.12 astronomical units. Here we can observe that the mass has nothing to do with the radii of the stars. Finally, we have Stephenson 218, the largest known star, whose mass is about 40 solar masses and has a radius of 10 astronomical units. Do you remember what I had explained to you? That kilograms are way too small for objects. Now imagine how sun masses are way too low for enormous stars, black holes, galaxies, or groups of galaxies. If we were able to put black holes next to our Sun, we would see that thanks to their infinite density, black holes whose mass is less than 100,000 solar masses would be kind of small. Look how big is a million times Sun mass black hole. Let's see for instance Sagittarius A, the black hole that is in the center of the Milky Way and is estimated to be at least 4.3 million times the mass of our Sun. Oh, I almost forget it. One Earth mass is equivalent to 5.972 times 10 to the 24th kilograms. One Jupiter mass is equivalent to 1.9 times 10 to the 27th kilograms. And finally, one Sun mass is equivalent to 1.989 times 10 to the 30th kilograms. Then we have other units. The most important is the measure of radius. You watch it that is measured in Sun radii, where we ran out of scale because those stars were too big, so I had to use astronomical units. There are also Earth radii measurements for telluric planets. and Jupiter radii for gas giant planets. The luminosity follows only for the Sun, and other units are quite standard, like Kelvin for temperature, meters per second for velocity, hours, days, and years for time, and so on. If I observe that this video peaks, maybe I will make another talking about these units. That's all for today. I apologize for my English, if there were any silly mistakes, but with practice I expect to improve my level. I hope you have understood me and see you on the next time.